So translations in the coordinate plane. Hello, eighth grade. Translations are just a form of transformations. Okay, remember we just did rotations? Well, here we're going to do translations. And that's when you move an object. Okay? So let's look at this problem here. Roberto uses a computer design program to make stickers. I guess this is the sticker he's going to make. He draws triangle ABC in the coordinate plane as shown. Then he translates ABC 5 units to the left to form A prime, B prime, C prime. What are the coordinates of the vertices of A prime, B prime, C prime? Well, one thing I want to mention is these little marks that I've said is prime, they look kind of like ones. So I kind of think of this as the first new figure made from this original figure. Now this kind of looks like a one, and this doesn't have anything there. And what is kind of like nothing? A zero is kind of like nothing, and a zero also kind of looks like an O. So I kind of think of this as the original, like having a zero there for original, and then this is like one for the first remake. It's just how I kind of remember that this one is the original and this is the remake. Because this is called the image and this is called the pre-image. But I just wanted to clear that up. Okay, so let's look at this. He translates triangle ABC 5 units to the left to form a new image. Okay, so we take each point and we go 5 to the left. And there would be A prime. And this one here, C prime, B prime. So this would be our new figure. Maybe I had to do it in a different color. And so then once we connect all of those dots, well, you can even see what the coordinates are before you connect them. But once I connect them, we see that this one is to the left one and up 1, 2, 3, 4, 5, 6, 7, 8. So this is -1, 8. Okay. And this one here is -1, 4. Which was B prime. And this was A prime. And this one here is -4, 5. And if you noticed that the y value stayed the same, and we subtracted 5 from the x value. Okay? So when you look at this, it went 5 units to the left. So if you look at this, what's going left? The x, and it's going down. So when you go to the left, the numbers go down. So 5. So the x value went down 5 because it went to the left 5. Okay? in Roberto's design, triangle ABC transforms to or maps onto A prime, B prime, C prime, or the image ABC. This means that vertex A corresponds to vertex A prime. See, so here A corresponds to I prime, B corresponds to B prime, and C corresponds to C prime. Okay? A with that little line is read A prime. Naming an image using prime notation helps identify corresponding vertices. Look at the table. How do the coordinates of the point change when it is translated left or right? So here now is an original point, 4, 8. So if we go 2 to the left, we see what axis is the left-right axis. That's right, it's the x. And to the left on the number line, the numbers get what? Smaller. So it wants to go smaller by how many? So the x value, it's an xy ordered pair, and the x is going to get smaller because it's going left by 2. So this is the x. It gets smaller by 2. Okay. Now we went 4 units to the left. So we look at the, now, okay, left is x getting smaller. So x gets smaller by how many? 4. So we look at this xy, and if 4 gets smaller by 4, we have 0. Now we translate 2 units to the right from this xy coordinate pair. 2 to the right. And on the x axis, when you go right, the numbers get bigger. Okay? So we went, it's still the x coordinate getting bigger by how many? 2. So 4, 2 bigger is 6. Now the x value got bigger by 4. So we look at the x value of 4, and we add 4 to it, and x is now 8. Now the y stayed the same because it didn't go up or down at all. It just went to the right. Okay? Now it's translating up and down. Okay? And when we look at a coordinate plane, and we're looking at up and down, which is the coordinate plane axis that goes up and down? Correct, the y-axis, which in an ordered pair is the second number. So that's going to change. If it goes up, it's going to get bigger. If it goes down, it's going to get smaller. So this one went up by 2. So up is the y-axis, and we're going to go up by 2 on the y-axis. Here's the y-axis. Up by 2, we get 10, and the x stayed the same. Now we're going to go up 4 units. 8, we're going to add 4 to the y-axis because we're going up, and we get 12. Okay? Now we're going to go down 2. We subtract 2 from the y-axis because when we go down, we get lower by 2. So down 2 is 8. And we go down 2, we get 6. And then down 4 from 8 is 4. Here's the point. 4, 8. 1, 2, 3, 4, up 8. 1, 2, 3, 4, 5, 6, 7, 8. There is the point 4, 8. Okay? So we have the point 4, 8 right here. And if we go up 2 units, we get to here, which would be 4, 10. Now, if we went up 4, we would have gotten up to here, which would have been 4, 10, 12. Excuse me. Now, if we go back to this original one and we go down 2, it would be 4, 6. And down 4 would have been 4, 4. Okay? So we're just moving it up and down, and the x value stayed the same of 4. And it was the y values that changed when we went up and down. This was 8, 6, 4, and then, okay, so 8, 6, 4, 10, 12. What are the coordinates of the xy translated? So if you have a point that's xy and it goes 5 units down, so no matter where this xy point is, if we go down 5 units, is that y value getting bigger or smaller if we go down? Is that y value getting bigger or smaller? Right, smaller when it goes down. So no matter what that y axis, that y value is, that, of the ordered pair, whatever the x is, the x stays the same. But we look at whatever the y is and we subtract 5 because it's going 5 down. So whatever the ordered pair was, the y is now going to be 5 less.